What's going on YouTube? This is Ipsec and we're doing Canape from HackTheBox, which I like this box a lot because in the very beginning, it forced you to do a lot of different things with your Recon. Every page returned as a HTTP 200, so you had to find a way to work around that. The word list I've used in pretty much every box, it didn't find a directory, and that directory was pretty darn obvious. It's .git. .git. I have no idea why that's not on the word list. I'm guessing maybe the word list is just old and before Git was a thing. Don't know, but it really reinforces that when one thing fails, and if you can run in the background, just switch to a different word list. Just do it again a different way. And eventually, hopefully, you'll find something that works. So let's just jump into the box. Like every other box, we're going to start with the nmap. So nmap-sc for default scripts, sv, enumerate versions, oa, output all formats, put in the nmap directory and call it Canape, then the IP address, which is 10.10.10.70. This can take some time to run, so I've already run it. Looking at the results, we have just one port is open. It is Apache listening on port 80. It's running version 2418 and is Ubuntu, so we know this is probably Ubuntu Xenial. If you didn't, you could look at Launchpad and look at what versions of Apache come bundled with what versions of Ubuntu and determine that. So let's just go and look at the site. So going to 10.10.10.70, we get the Simpson fan site. So let's just poke around, open things in tabs. Whoops. Everything we see. Look at the page source. Temporary hide check. So that's unique. Let's look at /check. And method is not allowed. So we got something to look at there. Pulling up the page source again. I don't know exactly what that is. It looks like a MD5 sum. I'm going to copy this, echo-n, paste that in, wc-c, 40 characters, so I believe that is SHA-1. Scrolling down, don't really see anything else. So let's look at what this page has. So this is exactly what we saw. We got a quotes thing here. Homer, Marge, Bert, Maggie, Lisa. So all Simpson characters and favorite quotes. Submit a quote. Let's put junk here. Seems to be an error. We don't recognize that character. So let's put Homer and junk here. So looks like that is fine. Well, looks like we can submit any character as long as that character exists. We can put anything we want in the quote. So we can turn burp on and go to Foxy Proxy, use burp suite, submit this, put this in repeater just to save it. And we'll call SQL question mark and keep going with this. More quotes, same page. So let us check this one as well. For this request, go to check, send this in, and I don't know what this is. So we can close that one and leave these pages up. Always should have something running in the background for enumeration, so I'm going to run GoBuster with -w for word list, user share word list, Dirbuster, then directory list 2.3 medium.txt, -u for URL. We want HTTP 10.10.10.70, and then I think it's -o for out file. We'll do GoBuster norm.log or whatever. And GoBuster doesn't run. It says wildcard response found, so to force processing do -fw. I want to do that first, and everything is responding with 200, which obviously is not good. If we go to the Simpson site, let's turn intercept off and put a few things. So 10.10.10.70 ASD. That was odd. Huh. Weird. No idea what I just hit, but doing random characters did something. I'm gonna see what that is. That looks like base 64. Or yeah, maybe base 64. I'm not sure exactly what's going on there. I didn't think I could just hit random characters and have something trigger. Okay, but what you're supposed to see is most of the time things are giving 200 responses. I guess if it's a long string, there's something odd going. But if we go back one, hit this again, it's not giving us that response every time. So that's why I go through burp, and we can see a little more what's happening. Response. So it is sending a 200 there of a length of 403. Maybe that's a troll. I don't know. But the key thing to note is everything is sending 200 responses, which is throwing GoBuster off. So when that happens, I do wfuzz. So let's do wfuzz, then -h for help. And the key things we want to do is hide responses. So wfuzz -w for a word list. We'll do the same word list. I would hit Alt and period, go through my arguments that I've typed previously, and get that quickly. 10, 10, 10, 70 / fuzz in capital, all caps. And wfuzz is going to see fuzz and then go through this word list, putting it all. So we hit enter. We see all the 200s, and we want to do -- we'll do HW for 1. Anything that's one word, we don't want. And I'm guessing that is going to be this random junk. So we're going to hide that. And I also see 3,076 characters repeated, and also 237 words. So we could do probably comma 237. I'm not sure how to hide multiple things in the same argument, but I'm going to do -- for hide character 3076. And H may not be intuitive for character, but keep in mind there's also code. So that's why character is H. Do this. And now we have wfuzz enumerating actual pages. So let's go back over into burp and see what we can do. We're going to grab this repeater request, the SQL. We can copy to file, and we want to do it in Canape. So this will be submit.request. Open a new window, SQL map -r submit-request, and enter. And that's going to start going, and we can play with this check. If you remember, we just got method not allowed. So I'm going to send this, or not, it's already in repeater. I'm going to change request method into a post and see if it accepts this method. And there we go. We got 400 bad requests. So we could manually do things like file equals A. No, ID equals A. And we get a different thing. Internal server error. Did we get that before? No. So just testing common parameters. So ID equals 1. Internal server error. ID equals B. So we're just trying to guess exactly what this request is. And we're not going to get there. You can do wfuzz just like I had done before and specify that. And that's what I had done. I'm not going to do it for the sake of the video because we do wfuzz with post and other videos. I'm not sure off the top of my head. But if I remember, I'll put it in the description. And oddly enough, this default word list isn't going to find it. So that's where you do other word list as well. And that's one of the things I like about this box is it's something that is, I guess, real world. that just doesn't exist in the word list we always use. There's not one word list for everything, and that's why it's always beneficial to have Recon going in the background, because when this finished in probably 20 minutes, if I didn't set up another one, I'd completely miss this for quite a while. So let's just pretend it's been 20 minutes. This word list finished. I didn't see anything. I'm going to go into SecList, and we're going to do discovery. And we're going to pick web content. And look at what we have. 120 different word lists here. I'm just going to do common.txt and see what we have. And right immediately, we have .git found. So if we go into a web browser, go into .git, we can see it's got git, I guess. Look at config, we see the URL is git-canape.htb/simpsons.git, and that's important because if we just do it via the IP, the Git program is going to pull this config and put this host name there and try to download the rest of the things. So let's try git clone, paste this, and just do the parent directory. And info refs not valid. Is it a Git repo? If we go there, let's see what it says. If it has links to git.canape. Weird. Let's just go into config. There's things that you just assume work, decide to dig deep for the video, and find out it doesn't work. But probably just doing something silly. Let's go into our host file, add the correct name, and this can be 10.10.10.70. While we're in here, let's just do canape.htb as well. Save this, and let's go to git.canape.htb. I think I said HTML back there. Specify the HTTP. That's the host, git. I bet this is some weird caching issue. Advanced, clear, settings, that's fine. I don't think it's realizing I edited my host file and it's just doing what it assumes is an invalid request, and then going to Google to search, or Verizon because my DNS, or ISP, whatever. Let's see. Let's try it again. It's been long enough. Nope. Let's disable burp. Maybe it's cached in burp. No. File. Private window. We'll get there. There we go. Get canape.htb with the private, so we're not doing any caching. Just gives a blank page. So we got a different website here. And this is doing I forget what the option is in virtual host routing in Apache. So now if we go to info/refs, still doesn't pull anything. We go to .git. Doesn't. Let's just try to git clone this and see if it works. And if it does, magic. And someone will explain in the comments. So git clone, git canape HTTP. We gotta specify HTTP. And dot. Do we do it? Oh, what am I missing? I think I sidetracked and forgot to do something silly. Git clone. There we go. I had to specify simpsons.git. Oh my god, I'm an idiot. This is a directory, isn't it? Yeah, that's gotta be something. Anyways, a little bit more messy than I'm used to, but we got there. So now we have a git clone. We can see the .git, and if we do git log, we can see multiple commits. And this is always something handy to do, because if we scroll down, we have like a commit where it says temporary hide check due to vulnerability. So that's going to stick out like a sore thumb. I'm going to go and look at that. So we're going to do git diff on that and see what's changed. So we're importing a few other things. We got C Pickle right here, and I know there's a vulnerability there. It's communicating with a CouchDB server. It's a Flask app in Python. So we're getting a lot of good things. And then we see this was removed on /submit. And it looks like it was submitting straight data into Pickle. And the template here was hide vulnerability. So now instead of going straight into Pickle, it looks like it's going into a file. So looking at this code exactly, we are taking the character and quote from the HTTP page, going to, I'm going to burp. We go here. This is the submit page. It's taking Homer and whatever a quote is, and base64 encoding it, then throwing it into Pickle, into a file. Oh, I should be looking here. I was looking at this, but no. This is the code that's on the server right now. So if char is not in quote, error true. This is going to probably be character, quote, error true. So Homer has to be, or a character has to be in both character and quote right there, is what I'm saying. Nope, I'm missing the nots. Oh my god, I'm so confusing. Forget the last 5 seconds. If not char or not quote. If either of these are not defined, error is true. Now we're going into an else. And this is the whitelist, and C is going to probably be character. So now we're looking at the whitelist. If we search what whitelist is, we see the whitelist is Homer, Marge, Bart, Lisa, Maggie, Mo, Carl, and Krusty. So this is where it's searching and verifying we have one of those characters in. Then it's going to create the ID by doing a MD5 sum of the character plus quote, and then hex digest is just going to grab the hex. So essentially MD5 sum character plus quote, and that equals ID. I'm going to guess that is the ID field of this check. And now we're opening /temp PID.p. So it is saving the character and quote to a file, and then opening that file and writing it here. If we look at the check, I'm going to assume it's going to pull ID and then grab the file and do something with Pickle. This is probably really hard to follow. This is why I don't like doing live streams or code analysis, because sometimes it's hard to explain things as you're looking at it. But we look at check, and check is going to be this request. And we see it's going to open the path, and this is going to be the ID. So we're trying to open the file we just wrote with submit, and then we're doing a pickle to load data, and then else item equals data. So we know we have a pickle vulnerability, and if you wanted to, you could Google like Python pickle exploit, and you get a bunch of things. This is, I guess, one to explain. So there is a Black Hat talk from, I think, 2011 called Sour Pickle, which explains this in depth and does a great job. Unfortunately, it takes a while to explain it. That video is an hour plus long. So essentially, Pickle's like a Python serialization, and you can't pickle something. Some things just don't serialize well, such as file objects, network connections, data connections. So Pickle calls reduce to clean those up. Otherwise, the code would just error and your program would crash. So it uses the reduce function in Python to clean it up as it does pickling. So the exploit is we actually serialize a new reduce call. So when Pickle calls reduce, it calls the code we just submitted. So that's what this is doing. So let us create that exploit ourselves. So we're going to do, we'll call this exploit.py. And I'm going to probably do this in Python 2. Let's look for like a print statement. Less init.py. Let's do it in V so we have syntax highlighting. Do they print at all? No. I'm not sure exactly what code this is. I'm guessing it's Python 2 because that's what most things do. So that's why we're choosing Python 2 to do this exploit. And I'm actually going to split this so I can look at the code as I write it. Some things help. So exploit.py, we want to do import os, import C pickle. We could probably just do pickle and not C. C pickle is like the C implementation of pickle. Not much difference in terms of exploiting, but since they use C pickle, I'm using C pickle. Next thing we want to import is their hashlib. So from hashlib, import MD5. And then we're going to import request so we can do the exploit ourselves and send it with Python. So let's create a class called please subscribe and define the object. And then we want to say def reduce self. And then return os.system. That's going to be the command we run. And then I think that's it. os.system command. Yep. So we'll fill this in later. I just want to get the skeleton of the exploit done. And then we want to do sc is equal to c pickle.dumps. Please subscribe. So what we're here doing now is pickling up this class. And then we can print it to make sure it works. We're in Python 2. And let's see. What else do we need to do? I think that's it. We'll have to send it. But let us pull a exploit code. So pentest monkey rev shell cheat sheet. And let's go to this one's always reliable. I always default to this one if I'm not sure and I don't want to do it 100 times. Okay. So let's look at the code, how we submit and what things we have to work around. So submit. Care is not in quotes, so we need to have if not care, not quote. So we can ignore this. That's not relevant to us. See lower. That shouldn't be too relevant. So this is what's relevant. We need the out file. And on check, do we have anything? No. This one is relevant. We need to put a character in this. and then it's going to write both the character and the quote to a file. And this is a little bit tricky now, because if we send it like, we can rename this now to Pickle. If we put Homer here in the character and then put a quote as the actual exploit, it's going to write Homer and then the exploit. And when we call the check right here and do the cpickle loads, it's going to fail because Homer isn't valid syntax. It's sending kind of a bad pickle because it's not 100% valid. The very first thing is wrong. So we have to put the character in the actual pickle so we can pass the check and whatnot. So in order to do that, I'm just going to put a shell command to echo Homer, exclamation point, and RM. And then we'll want to split the shellcode. So we'll split it on character and quote is equal to sc.split, exclamation point. So now whenever we print this pickle, it will split it up into two. And we'll show that. Char splitting string 2 print quote. So Python exploit.py. So, whoops. Okay. So here's the original pickle. And if we had Homer above the cPOSIX, the pickle's no longer valid. So that's why we put it as an echo thing here. So what we did is this is going to be the character, and this is going to be the quote. And then when it writes them both to a file, it's just one big pickle. So that's what we're doing there. Hope that makes sense. Makes sense to me. The other thing we have to do is the PID. And I'm just going to copy their thing, verbose plus quote x digest. And the last thing to do now is a request. So if we do, we could actually test this. So we'll do cpickle dot loads sc. We'll do char plus quote. I think it's plus in Python, maybe dot. We also have to change this IP. 10, 10, 14, 12. Use port 9001. And then if we run exploit nclvmp 9001, we get a connection. So we know our exploit works, or at least if it does a pickles load on what we're sending, it's going to work. So that's taken care of. So let's do request.post http 10.10.10.70/submit, then data to make this a post request, and it wants the character and the quote. So character is equal to char, and quote is equal to quote. That is for, oh, I said date, it's data. That is the piece for submitting it, and now we need the piece to check. So check, this is going to be ID is equal to PID I believe. And we could verify that by going into the code, looking at check, and it wants request form ID. So save that. We can exit this, clean it up a little bit, and nclvnp 9001 Python exploit, and we get a shell. So we could run the whole Linux enumeration script, but I don't think you guys have to see that every time. So first thing I'm going to do when I get a shell is Python import pty.spawn, and then bin bash. I need to put that in double quotes because I already use single quotes. ty raw minus echo. So I'm just going to do a ps-auxww to list everything that is running. And going through things, let's see. These are all system processes. That's odd. I'm not sure what that is. I see CouchDB is root there, and then we got CouchDB running as Homer. And because Canape is French for couch, I'm going to start here. And that's what I actually did on the box when I did it the first time, is I saw CouchDB in that code and realized, oh, that's probably something we should look at. There's got to be a reason this box is called Canape. So let's take a look at exactly what CouchDB is. If we do netstat alnp grep list, because I don't think CouchDB says what port. Doesn't. We did see CouchDB is at release 2.0.0, and we're listening on a few ports. If we Google, let's see, CouchDB port, we can see 5984 is the port. So if we curl 127.0.0.1 5984, we get welcome to CouchDB version 2.0 and whatnot. So let's see if I can pull this up quickly. Why am I typing echo? CouchDB usage. Or maybe we'll search API. API reference. This will probably be good. So we can see things to do. So let's do a curl against all DBs. So curl all DBs. And we can see the databases it has is global changes, metadata, replicator, user, passwords, and Simpsons. So if we do all DBs, Simpsons? Nope. We just curl against Simpsons. We can see the data inside of there. And I think we can do all underscore docs and see the docs within Simpsons. And then there is a command to do all docs and recurse. CouchDB examine all docs. I'm not sure what it is. DB all docs. Do we have it giving us an example of how to go inside the doc and request? We do not. So we'll just do Simpson and then the document ID. And we can see the very first quote, Simpson, and the next one. So we know this database is full of all the quotes. Let's go into the passwords database. So if we curl against passwords, we get we're not authorized. So if we had searched, let's see, CouchDB 2.0 exploit, we see there is a exploit DB article. I'm just going to pull up in searchploit. So searchploit dash CouchDB remote command execution. This is looking good. We searchploit dash X on it. We can see what it's doing. So the very first thing it does is a check to get the version. And let's see. So we're doing a payload against, let's see, users or CouchDB user plus a username. And this line is odd. We have it crafting a payload and the type username, and then we got, let's see if we can pull up CouchDB create user exploit. Not always the easiest to read code. If there's any write-ups for it, it'll be a bit better. Vulnerability. Here we go. So they're doing this through curl. We can see it's doing a put request to this, and then they're doing a little bit of something like type confusion. And they're putting the roles as admin, the roles as nothing, and password. And I think the vulnerability here is you can create a user, and JavaScript is going to just look at this one, and it's going to be like, hey, you're not requesting admin role. Go ahead and create that. However, the backend processor, which is Erlang in CouchDB, is going to look at both of these and add you into the admin. It's something like that. So that's what this is doing. So let's create our own user. And then it's doing this piece that actually doesn't work to actually execute code. Not sure why, but we'll test it out and verify. It's a -c to copy. I forget what copy is. Searchploit -h case exact JSON mirror. I'm going to copy that exploit here, but we also want to do this. So set paste. Instead of creating the user oops, we're going to create the user ipsec. So we're assigning this as a user. Yeah. The name of it is going to be ipsec. It's going to be an admin. And then that second role, that's the exploit. And the password is going to be please share the video. So that looks good. We're going to cat this and send this in and see if it works. Curl. Oh, that was odd. I guess it didn't like something how it was written. Weird. Just paste this again and see if it works. Curl-x post HTTP. Oh. We probably should be doing this against. Let's see. Two things wrong. The first thing, this should be on that line, or we should have like a backslash at the end. So catexploit.sh, and then we also have to run this on a Canape session. So now we see okay, true. So we added the user ipsec, and if we now go to a history and look at the passwords thing, it's not going to let us without a user. We can see that we're still unauthorized. And in code, we're going to specify --user ipsec, please share the video. And now we can curl this passwords table. So let's do passwords all docs. And we can see, just like in the other one, we have documents with IDs. So let us curl all passwords in this. And we see item, SSH, password, this, user, I don't know. Doesn't give us the user. So let's just curl all these. And again, there's a flag in all docs where you can actually have it do this for you. Don't remember it. I should have taken notes or something and looked at it before recording. So, see a few things. We have SSH password and this, CouchDB password, relax on the couch, Simpson fan club password, whatever, users Homer, HomerJ02 GitHub password, stop storing your passwords here -admin. So, guess he doesn't like people storing the passwords. But if we cat etc passwd, we should see there is a Homer user. There he is. Homer's there. So let us grab the password that says SSH and just try to a su Homer dash and put his password in. And now we get a shell as Homer. So we should be able to go to /home/Homer. And there's user.txt and a bunch of other things. So I'm going to do a sudo command because the thing I was looking for is, does this person have like sudo privilege to start CouchDB? No TTY present. Then bash sudo-l, enter his password. And we can see that he is allowed to run pip as root. And there's been boxes that have the same vulnerability but with different package managers like npm. So all we have to do is create a malicious Python package, then we can install it as root. So let's do that. The first thing we want to do is create a directory for our exploit. So we'll just call this, I guess, ipsec, go into it, and then create a setup.py file. Go over to pentestmonkey, and we want to copy the Python script. And we can clean it up. Okay, there we go, it's typing. I think just /n would, maybe /n. I always forget how to add lines. That would be fine. Doesn't have to be, but it's just nice for aesthetic purposes. So we want 10, 10, 10, 14, 13. We're already using 9001, so we'll do 9002. Save this. So new shell on 9002. Then do sudo pip install, and then the current directory. And pip's going to go and execute setup.py to install it. And given we did everything correctly, it will give us a shell. Doesn't look like we did everything correctly though. Let's see. It's not owned by the current user. Check the permissions and sudo's -h flag. ps-ef grep pip. What did I screw up? Let's see. I can't kill it now. That's for sure. It's running as root. 10, 10, 14, 13. Is that my IP? Ten 1412. That's an easy mistake to make. Let's try that. So let's do sudo pip install dot now that we have the correct IP. And there we go. We do ID, we are now root. And I don't see root.txt, but we're in a temp directory, so there we go. We do wc-c root.txt, and there's the box. I do want to go back though, and we're going to look at doing the escalation of Homer a different way. And that way is going to be through Erlang, but I'm going to show exactly how I found out about that. And I saw something similar by Mubix, Rob Fuller a few months ago doing it with kind of a different thing, but I'm going to show the path that I found to get into CouchDB. So credits to Mubix for finding this first. But yeah, let's begin. The first thing we have to do is get a shell. So we can exit out of this, exit. Let's just close everything. So that's all closed. That's good. Let's get a netcat shell on 9001 and let us run exploit.py. So this is where we were before. We were dub data, and this is all we had. The original exploit did say that it was code execution. I just said it wouldn't work. So I'm going to dig into that and research this, because this is what I was doing before the video, trying to get this to work, because I didn't get this to work actually when I was doing the box. So let us copy this all. And then we will paste it in, because again, the CouchDB is listening on a local port only, so we can't do it remotely. So let's just vi exploit.py, where you have to do the Python thing, and then the tty thing. So let's just go into dev shm for a clean working directory. Export term equals screen. There we go. Now I can clear. So v exploit.py, paste it in, and I copy an extra r. There we go. So if we look at this exploit again, we see the example usage. And that's just going to run ID. So if we execute that, whoops, Python exploit.py says command executed ID. And I didn't see any output from that. So let's try this again and put this. Does not like my terminal right now. Wow. Do temp ipsec. Clear this, do history, and we see it magically typed it all correctly. So do ls-la on temp, grep for ipsec. We see it didn't actually create that file, so we know the command execution isn't working. We tested for just running the exploit script and seeing if it would print it out, didn't, and then made the exploit script send it into temp, and we still don't see it. So let's take a look at exactly what that exploit script is doing and do it manually and see where it's failing. So we see a git version right here and def exploit. See, this is it creating a privileged account. Let's just delete this, get this out of the way, because we already have a privileged account. create the payload. So if version equals 1, do this, else do something else. So the first thing to do is check the version, which is here, and that's just doing a request.get and decoding the JSON and pulling the version variable. So let's do curl localhost, was it 5984? Yep, and we see version 2.0. So we know that version is not equal to 1, so this code is out. The only thing we have left to do is now start this. So it's doing a request to underscore membership and pulling all nodes. So let's do that. Underscore membership, then all nodes. You're not a server admin, so let's do the -- user ipsec. Oh my god, that's gonna be annoying. Please share my video. And let's see. STTYA. It's because I did that screen thing, I think. Let's just export term is equal to that. Is that going to be fine? I forget the line and column thing to do. So let's see if this works. User ipsec, please share my video. Did that create? I got the password wrong. Let's just, I guess, create a new thing. So probably create that in /. Grab exploit.sh. Oh, it's going to be in the script. Please share the video. What did I put? There we go. So now we're querying that membership all nodes. Unknown error function clause. That's not what I expected. Underscore membership. Okay. Querying underscore membership and pulling all nodes. So we're pulling CouchDB at localhost. That is the variable. So the next thing to do is underscore node host and then config query servers cmd. So what was it? Node host, which is going to be CouchDB at localhost. Because we're doing this, have an at's a weird character that terminals don't really like. I'm going to put the URL in single quotes so we don't process that @ sign. Then I think it was underscore config. Let's see. Yep. We can just run that and we can see the actual config of this CouchDB thing. So we know the command is valid up until that point. So the next thing to do, query underscore servers. And we see it's valid up to there. Search for CMD and we get unknown value. So let us see exactly how it's doing that. It has data here, so we know this is a post request, and it's adding just a command with double tick and single tick. So let us do that. -d, and then ID. Method not allowed, so -x put. I keep saying post, I guess it's put. The -d is going to make a post, so we want to put it as put. And we get a weird error message of saying something about bad RPC.erl, which is Erlang, but a bunch of error messages. So what I was doing is I figured, okay, well, if we can create a new, well, I was thinking it was something in this config. So my logical step was, okay, let's see if we can create a new membership name or a cluster name and make like IPsec at localhost and then change the config value, and maybe we'll be able to get code execution that way. So went over to Google and did CouchDB Cluster setup node. We go to this page, and reading this, we see if you expose port 4369 to the internet or any other trusted network, the only thing protecting you is the cookie. So I had immediately decided that sounds interesting. Let us do a netstat ALNP grep. What was the port? 4369. And there we go. It is listening. So doing more research into this, we look at the cookie. It's distributed Erlang. And we can see we can set up a connection up there. And it's saying it's a distributed protocol. So the next thing to do would be Google Erlang run command on remote node to see if that's possible. And learn you some Erlang sounds like a good thing. And reading this whole blog post about Erlang, eventually we get to a spot that says setting up a Erlang cluster. There's the Erlang-s name we saw. Now we can connect to it. And this is the secret. Running node to see the nodes on it. We can register, run commands, receive commands from other nodes, things like that. So the only thing we have left to do is find out what this cookie is. So if you just look at GitHub CouchDB, pull up the page, and search for cookie, we can see, let's see, do we have it? We have the cookie and the node name right here. So, and I think I misspoke when I was scrolling through this. Let's see. Erlang S name. Where do they set the cookie in this page? There we go. You set the cookie up here, and then you can connect to the node name. So if you read this whole thing, you know to do ERL-S, and we'll call this, we can call a cluster name anything we want. So call this IPsec-set cookie. And the cookie we had saw in GitHub was monster. Home must be set, so export home is equal to dev shm, I guess. Do that again. Oh, S name. There we go. And now we're in a Erlang shell. So we can try editing commands on a remote host. Netkernel connect. So that's what we have to do. Netkernel connect. And then the name was CouchDB at localhost. And Erlang likes ending commands with a period, not a semicolon, not anything else. And we can see it connected true. If we put something bad there, netkernel connect localhost, we see false. And we can see, I think we are still, we're not connecting anymore because we did that second one. Let us try that again. True, node. Is it nodes? Nodes, okay. And that'll show the remote node is CouchDB at localhost. So the final thing to do would be Google Erlang execute shell command. And let's see. We'll do OS command. I think this is the same page that was there. And this page does have it, so we can say OS cmd who am I? And we're still dub data, but we haven't tried to run it against the remote host. So again, you go back to this whole post. Remote shells, hidden nodes, RPC, remote procedural call, the host, and then the command. It looks like essentially instead of spaces, you do commas. So we'll try that. RPC call, specify CouchDB at localhost. Then we want to do OS CMD. Again, just pulling this, and then send it, who am I? Put a period, and it says Homer now. So we ran this command on Canape as the Homer user. So the final step to put this all together is starting another netcat listener, lvnp 1234, and we just got to get a shell. So we can do OS command, and let's try echo test to see if this works. Syntax error. So we can do OS command echo test like that. Bad RPC. So this is the same exact error message we had pretty much got from the CouchDB. So playing around with this a little more. So let's just see exactly how we're supposed to do this OS command. So I'm going to go back to Google, and when you're doing a new language, you do this a lot. I'm just going to do Erlang OS CMD. And how do we call, let's see. Try this to see if they're doing ls in any directory. And it looks like they are not. So we can close that one. Try this. And they're putting it in quotes. So maybe Erlang just doesn't like spaces. So it's odd to me that who am I works without quotes, but maybe it works with quotes too. Let's try that, and then we'll try it with a space. So we're just trying to figure out exactly how the heck this works. And yep, it works with quotes as well. So let's go back and do echo test. And we see that works as expected. So we can go back to our trusted pen test monkey for, I believe, the third or fourth time and pick a shell. We could try this netcat, but it has a lot of weird characters. So the very first one I'm going to try right now is this bash one. So we want 10, 10, 14, 12, and 9003, I guess. And then 0 and 1. Close that. And hope for the best, I guess. We'll see if this shell works. And this is where it becomes trial and error right now. So nc lvnp 9003. Enter. Syntax error. Bad file descriptor number. So I don't think it liked any of the pipe characters, which is a shame. So let's see. We can do echo ls and pipe it to bash. and that will execute. So I'm going to base64 encode this command to get rid of all these special characters and then do it this way. And we'll see if that works. So echo-n, put this in single ticks. Let me actually put that in single ticks in Erlang, see if that matters. I don't think it will, but never know. So single tick. Single tick. Still bad file descriptor number. So looks like a command. Base64 it. We can type it correctly. And then we can, I should have copied that later. I've done this in a split pane. RPC, copy this, echo, paste. Everything looks fine there. I was just, again, checking all the special characters it was using, the plus and equal and whatnot. So we can do echo-n. We don't want that line break there. Oh, not line. Yeah, the line break. Or new line. And then send that to bash. And we'll see what happens here. Oh, base64 then bash. Base64-t, bash. And it's hanging right now, which means we got a shell here as Homer. So that is the box. I hope you guys enjoyed that little second priv-esque using Erlang. So, yep, take care, and I will see you all next week.